Hi class, welcome to our lesson in General Chemistry 2. This is Sir Alex Pasco and this is our lesson 6.4. Today we'll be discussing about the colligative properties of solution. This is the last part of our discussion about solution. So let's begin by understanding what would be the goals of today's lesson. The goals includes for us to be able to describe the effect of concentration on the colligative properties of solution. Next, for us to be able to differentiate the colligative properties of non-electrolyte solution and of electrolyte solution. Also, for us to be able to calculate the boiling point elevation and the freezing point depression from the concentration of solutes in a solution. And lastly, for us to determine or calculate the molar mass from the colligative property data. So let's begin our discussion by understanding what is the colligative properties. So a solution will behave differently from a pure solvent because of the particles of solute present in solution that affects some of its physical properties. What that means is that if we have a pure solvent, for example, just pure water, it has a lot of different properties which we have discussed long time ago, which includes vapor pressure. It has its freezing point at 0 degrees Celsius at 1 atmosphere. The same thing, it has its boiling point at 100 degrees Celsius at 1 atmosphere. All of those are the properties of water. But when we add solute into that water, for example, a tablespoon of sugar, or for example, a pinch of salt, those properties actually changes. So depending on the number of solute present in that solution, meaning the number of the solute particles we added onto our solvent, in this case the water, those properties actually changes, meaning the boiling point, the vapor pressure, and the freezing point of the water actually changes when we add solutes into that solvent. These properties that changes that depends on the number of solute is what we call the colligative properties of solution. Again, the colligative properties of solution are basically the physical properties of a solution that depends on the number of the solute particle in the solution. Sa madaling sabi, yung colligative property ng solution nakadepende siya sa kung gaano karami yung number of solute na meron doon sa solution. At yung mga colligative properties na ito includes the vapor pressure lowering, which means the vapor pressure of the solvent actually lowers when we add solute into the solvent. The freezing point depression, which means the freezing point actually decreases when we add solute into the solvent. Boiling point elevation, the boiling point of a solvent increases as we add solutes into the solvent, making it a solution. And lastly, the osmotic pressure. So the osmotic pressure also changes depending on the number of solutes. So to understand this, let's take this as an example right here. So on this flask, we have pure water. And if you guys remember the vapor pressure is the rate or is the pressure exerted by the gaseous phase present on top of the liquid. So in this portion right here, you have your water, H2O, in liquid form. And you know that at some point, some of the H2O molecules would move from being a liquid to gas. And that change in gaseous phase, uh, that's why we have some gas particles on top of here, dito. These gas molecules exerts pressure. What happens when we add solute into this pure water is that the vapor pressure actually lowers. As you can see, there are less um, gas particles on top of the liquid. That is because some of the solutes, some of the solute particles stays on the surface of the water. So they actually block some of the liquid particles of water, and they cannot move from being liquid to being gas. So that's the reason why the vapor pressure lowers. If you guys remember, yung vapor pressure is simply na yung H2O, nag-change siya from liquid form from here, mula dito. Kapag nag-change siya, magiging siyang liquid, it escapes the liquid form, it becomes gas, and that gas molecules exerts a vapor pressure, a pressure. And kapag linagyan natin ng solute, yung tubig, yung pure water, yung ibang particles ng solute, nagre-rest sila dun sa surface ng water. Even though even if we dissolve them, some of those dissolved particles rests dun sa surface ng water. What that means is that there are less water particle or water molecules, H2O, that shifts from being liquid to gas. And if there are less H2O molecules that shift from being liquid to gas, it means there are less vapor pressure. So that's how um, solutes in a solvent, or basically now in this solution, lowers the vapor pressure of the solvent. The same thing happens with freezing point depression. The same thing with the boiling point elevation and the osmotic pressure. Depending sa kung gaano karami yung solute na meron yung solution mo, it affects these properties: the freezing point depression, boiling point elevation, and osmotic pressure. In today's lesson, we'll be focusing more on the freezing point depression and the boiling point elevation. So let's begin discussing freeze. Oh, before we start discussing freezing point depression and the boiling point elevation, I want you guys to remember, since the number of solute in a particle per solution is basically a concentration, and the concentration that we'll be using in today's lesson is mostly molality. If you guys remember molality, molality usually expressed with small letter m is equals to the moles of solute divided by the kilogram of solvent. So this is the concentration that we'll be using in determining the number of moles or the number of solute particles present in our solution. Okay, so now let's begin discussing freezing point depression. From the word depression, you think of it as the mental illness, but depression simply means going down. So freezing point depression is that when we add solute into the solvent, making a solutions, in order to freeze that solution, we have to have a lower temperature. So ibig sabihin, yung solute, binababaan niya yung freezing point ng solution. The decrease in freezing point of a solution compared to a pure solvent is called the freezing point depression. The freezing point depression is basically how much lower do we have to lower our yung freezing point to turn our liquid solution to solid. You know, if you guys remember, freezing is from liquid to solid. To remember it simply, pure water, yung freezing point niya at 1 atmosphere is, if you guys remember, is basically 0.0 degree Celsius. That is common knowledge. But if we make a water plus solute, yung freezing point niya should actually be lower than 0.0 degree Celsius. So parang ganun lang yung principle niya kasi we added solute. Okay? And this lower freezing, yung amount na binaba ng freezing point is what we call the freezing point depression. And this freezing point depression is directly proportional to the molar concentration and molar of concentration of solute. And this is the equation that we use to find how much temperature change do we need? Kung gaano kababa yung freezing point or kung gaano kalaki yung binaba ng freezing point ng solution. We get that by multiplying Kf to the molar concentration of solute. So Kf or M is the molar concentration of solute, and Kf is what we call the freezing point depression constant or cryoscopic constant of the solvent. So this is the molar concentration of solute, and this is the constant of solvent. This Kf is usually most of the time given, unless it yung sinosolve mo, it is usually given in the problem. Also, you can search a different freezing point depression constant of different solvents sa internet, or there are a lot of them in books. So again, remember, usually given naman yung Kf, maliban na lang kung syempre ito yung sinosolve mo. Usually, bibigay nila nun yung delta temperature or the freezing point depression and yung molar concentration. So before we go into a sample problem for freezing point depression, let's talk about the boiling point elevation. Since the vapor pressure, diniscuss ko kanina yung vapor pressure, it lowers as we add solute to the solvent. So the vapor pressure of the solution being the solute plus the solvent, becomes lower because of the solute. It stands to reason that the solution's boiling point will increase. So meaning, in order for us to increase the vapor pressure to be equal to the atmospheric pressure, which is the boiling point. If you guys remember what the boiling point definition is, the boiling point definition is basically when the vapor pressure is equals to the atmospheric pressure. We've discussed this long time ago. I hope you guys did not forget that. But going back, since bumaba yung vapor pressure, it stands to reason that the boiling point should increase in order for us to increase the basically to increase the boiling point needed para maging equal yung vapor pressure sa atmospheric pressure. The increase in boiling point observed when solute is dissolved in solvent is called the boiling point elevation. It is directly proportional to the molar concentration of the solute. Meaning, let's say, remember, ang pure water at 1 atmosphere, yung boiling point niya, if you guys remember, is 100 degrees Celsius. Tama? Pero if we have water plus solute, ang mangyayari, yung boiling point niya is actually higher than 100 degrees Celsius. And that is, again, because of the vapor or because of the solute. And this increase in boiling point is called the boiling point elevation. And we can get that by basically multiplying Kb to the molar concentration of the solute. Again, M is the molar concentration of solute, and Kb is the boiling point elevation constant, or the ebullioscopic constant of the solvent. So this is the constant of the given solvent. And similar with Kf, Kb is usually given in the problem. Again, of course, unless it is the one you're solving for. Okay, so freezing point depression and boiling point elevation. Kf and Kb depends on the chemical identity of the solvent. So remember, Kf and Kb is related to the solvent, and it is usually given in the problem, or again, it can be looked up over the internet online, or sometimes if you want to in the books. Always remember to subtract the change in freezing point depression or freezing point to the normal freezing point of the pure solvents, and solute always lowers the freezing point. I've talked about this. Solute always lowers the freezing point. Okay? So what that means is sa pure solvent, kumbaga ito yung water mo, and yung temperature to freeze ng pure solvent is let's say is equal to zero point 0.0 degrees Celsius. When you solve for the change in freezing point, this is the freezing point depression, you have to subtract that to the normal freezing point temperature ng pure solvent mo in order to get the new temperature of the solution. Okay? Again, always remember to subtract the change in freezing point. So this is your delta TF, which is equals to KF multiplied by the molar concentration of the solution. You have to subtract this to the normal freezing point of pure solvent. So the normal temperature of the pure solvent in its freezing point, since we're talking about freezing, you have to subtract the delta TF to get the new temperature of the solution. Which basically means we're just rearranging the equation is that delta TF is basically equals to the negative of the solution, the temperature of the new temperature of the solution minus the temperature of the pure solvent. Again, delta TF is also equals to KF, or the freezing point depression constant multiplied the molar concentration. As for boiling point elevation, always remember naman to add the change in boiling point, delta TB, to the normal boiling point of pure solvent, since solute always raises the boiling point. What that means is yung original temperature ng solvent, ng pure solvent, halimbawa sa water, yung normal temperature niya to boil is 100 degrees Celsius. After looking for the delta change, or the change in temperature of boiling point, which is, if you guys remember, we just discussed, is equals to Kb multiplied by the molar concentration of the solution, is equals to the new temperature of your solution. And again, just rearranging the equation, we'll get that delta TB is equals to the temperature of the solution minus the temperature of the pure solvent is equals to, again, the KBM, or the boiling point elevation constant multiplied by the molar concentration of solute. Okay, so after solving for TF, again, let's go back here, you have to subtract this to the original temperature of the pure solvent, yung temperature na need niya to freeze, and you would get the new temperature dun sa solution. Similarly, or I mean on the other hand, after solving for TB, you have to add this to the temperature of the pure solvent, the boiling temperature of the pure solvent, to get the new boiling temperature of the solution. Okay, so let's put this into practice. So let's have sample problem 6.4.1. Calculate the freezing point and boiling point of a solution containing 4.27 grams of sucrose and 50 grams of water. The molar mass of sucrose is equals to 342.296 grams per mole. The Kf of water, again, remember Kf is related to the solvent. The Kf of H2O is 1.6 degrees Celsius per molal. M is not mass, it's not moles, it's molal. Kb of H2O is equals to 0.52 degrees Celsius per molal. Okay, so let's solve this. Let's move to the whiteboard in order for us to solve this. Okay, so let's begin solving this by first writing our given. So what's our given here? So the first thing that they gave us is the mass of sucrose, C6H22O11, and the mass of sucrose is equals to 4.27 grams. They also gave us the molar concentration or the molar mass of sucrose, which is the molar mass is equals to 342.296 grams per mole. Next, they gave us the um, KF, or the what do you call this, the freezing point depression constant of your solvent. Your solvent is H2O, is equals to 1.86 degrees Celsius per molal. And the boiling point elevation constant of your solvent, or in this case the water, is 0.52 degrees Celsius per molal. So this is always, since this is constant, this is never changing. So the Kf and the Kb of H2O will always be 1.86 degrees Celsius per molal and 0.52 degrees Celsius per molal respectively. This does not change. Okay. Next, what are they asking in this equation or in this problem? So they're asking for the calculate the freezing point. So the new freezing point of the solution and the boiling point of the solution. Again, so kung solvent lang, alam natin yung freezing point and yung boiling point niya, 0 degrees Celsius and 100 degrees Celsius respectively. Pero since mag-a-add tayo ng sugar, in this case sucrose, mag-iiba yung freezing point and yung boiling point. Remember, adding solute onto the solvent, ang mangyari dun sa solution, bababa yung freezing point and tataas yung boiling point. And the formula that we have to use are basically the formula that I've written earlier. So the amount of change on the temperature of freezing point is basically equal to the negative, the original, the new temperature of the solution. So the negative temperature of the new solution minus the temperature of the pure solvent. Which is equals to Kf multiplied by the molar concentration of the solute. And the new temperature, the change in temperature of the boiling point is equals to the solution, the new temperature of the solution minus the original temperature, the boiling temperature of the solvent, which is equals to KBM. Okay, so let's try and solve this problem. Okay, so since in order for us to solve for the freezing point, what we need is the molar concentration. In this case, they did not give us, so we need the molar concentration of C6H22O11. Kasi yun yung kailangan natin to get the delta TF. So we have the KF, ang kailangan na lang natin is M. And we can get that by kung naalala ninyo yung equation for molar concentration is the mass of solute divided by the kilogram of solvent. In this case, they gave us the mass of the solute. Moreover, they also gave us the solvent but in grams. So let's begin by first changing the grams of our solute. So the grams of our solute, so they gave us 50 grams of H2O, which is our solute, which is actually equal to 0.050 kilogram of H2O. So just unit conversion. Okay, so I'm going to show you how to do unit conversion. It's basically this. So you have 50 grams. There is 1000 grams of H2O per 1 kilogram of H2O. So cancel the grams. You're basically gonna get 0.050 kilograms. Okay, so after getting the kilograms of your solvent and you have the mass of solute, the molality is equals to the mass of your solute, which is 4.27 grams of C6H22O11, which is sucrose, divided by, oh, sorry, I have a mistake. This is supposed to be moles. So in order to forget, kailangan natin yung moles, not the mass. Okay. So to get the moles of solute, we have, so moles of solute is equals to the mass divided by the molar mass. Okay. So before, yeah. So let's go back there. So we need to have the molar concentration of your solute. In order to get the molar concentration of solute, first we should get the moles of our solute and the kilogram of solvent. So here we solve for our solvent. Now let's solve for our solute. We need moles. And they gave us the mass, and they also gave us the molar mass of the solute. So the mass of solute is 427 grams divided by the molar mass, which is 342.296 grams and grams per mole. And just using calculator, you would get 0.0125 moles of C6H22O11. So now that we have our solvent and we have our solute, we can compute for the molar concentration. So 0.0125 moles of C6H22O11 divided by 0.050 kilograms of H2O. And that would give us 0.25 molal. Okay, so after getting that, after getting the molar concentration, we can now solve for the freezing point. Okay, so the freezing point, the delta, the change in the freezing point temperature is equals to the Kf multiplied by the moles. So the Kf is given, which is 1.86 degrees Celsius per mole, multiplied by 0.250 molar concentration of solute. Cancel the molar, and that would give us equal to 0.4650 degrees Celsius. So this is not yet the answer because we are looking for the new freezing point. This is just the change. To get the new temperature of your solution, what you need to do is, remember, you have to subtract this to the temperature, in this case, the freezing temperature of your pure solvent minus the delta Tf. So to get the new temperature of the solution is equals to 0.0 degrees Celsius. This is 0.00 because the temperature of pure solvent, in this case your pure solvent is water. The freezing point of water is 0.00 degrees Celsius minus 0.4650 50 degrees Celsius, which is the change in the temperature. So the temperature of your solution ngayon, which is the combination of the sugars, the sucrose, and the water, is equals to 0.4650 degrees Celsius. So this is your new freezing point. This is the temperature that you need to freeze your solution. Okay, so let's go to solving the boiling point. Okay, so the delta change in the boiling point is equals to Kb multiplied by M. And the Kb is given by the problem, which is 0.52 degree per Celsius per mole. And we have to multiply the mole concentration of the solute we got earlier. Cancel the mole. And the change in the boiling point temperature is equals to 0.13 degree Celsius. Same thing, to get the new temperature of the solution, what we need is to add this time. So the temperature of the pure solvent, the boiling temperature of the pure solvent plus delta Tb. And ang mangyayari ngayon, the boiling temperature of the pure solvent is 100 degrees Celsius. Again, your solvent is water and your boiling temperature niya is 100 degrees Celsius plus 0.13 degrees Celsius, which is how much change it needs. And yung sagot natin ngayon is 0 or 100.13 degrees Celsius. So this is the temperature you need to boil the solution. So hindi na siya magbo-boil sa 100 degrees lang. You need 100.13 degrees Celsius to boil your solution. Okay, so sorry about my mistake earlier here, but that's how you solve for the new boiling point and freezing point of the solution. Okay, so let's go back to our lesson here. Okay, so that's how you solve for the boiling point and the new freezing point. Okay. Next, another thing that we can do with the colligative property is to determine the molar mass. So meron mga problem na kayong kanina dun sa problem natin, binigay sa atin yung molar mass. So paano kung hindi binigay yung molar mass? Using the data that we have in the colligative properties, since it is directly proportional to the number of solutes present in a given amount of solution, we can actually use those colligative properties data and the mass of your solute by yung kailangan mo lang is yung info ng one of the colligative properties. So you just need one of the either delta TBF or delta TF. So knowing one of these plus a mass of your solute, a known mass of your solute, you can determine the molar mass. So how can we do that? Let's use the sample here. So when 4.35 grams of ethylene glycol H6O2 is dissolved in 100 grams of water, the resulting solution has a freezing point of negative 1.31 degrees Celsius. So ito yung bagong, so this is negative, okay? Nandun yung negative sign lang, nakahuli. So this is negative 1.31 degrees Celsius. Calculate the molar mass of C2H6O2 or ethylene glycol. The freezing point of pure water is 0 degrees Celsius. So this is common knowledge. So ngayon ang ginagawa natin is paano kabaliktaran ng ginawa natin kanina. Ang hinahanap natin ngayon is yung molar mass. Ang ibinigay sa atin is yung grams ng solute, which is 4.35 grams of ethylene glycol, and ibinigay din sa atin yung new freezing point ng ating solution. So how can we solve for the molar mass? Let's go to our um, whiteboard. Okay, so let's begin by writing yung mga given natin. Okay, so our first given is they gave us the mass of our solute, which is C6H6O2, not C6, this is C2. H6O2, which is 4.35 grams. Next, ibinigay din na yung mass ng ating solvent, which is 100 grams. Next, ang ibinigay sa atin is yung new temperature. In this case, this is the new freezing temperature of our solution, which is negative 1.31 degrees Celsius. And ibinigay din sa atin yung freezing temperature ng pure solvent natin, which is 100 or 0.00 degree Celsius. Ang itinatanong ngayon is what is the molar mass of C2H6O2. I mean, you can do the normal table of elements, look for the atomic weight of each and then just add them after multiplying however how many elements you have. But in this case, we will have to, well, let's use the colligative property data. And the formula that you need to solve this is basically the same formula that we use. So delta TF is equals to the negative the solution, the temperature, the freezing point, the new freezing temperature of our solution minus the freezing point temperature of our pure solvent, yung normal freezing point yan, which is equals to Kf multiplied by m. Let's also remember kung ano yung equation for our molar mass. Molar mass, we can get this equation by using the mole equation, which is mass divided by moles. We get this from remembering moles is equals to mass divided by the molar mass. So just rearranging the equation, you'll get that the molar mass is equals to mass divided by moles. Okay, solution. Okay, so before we can find the molar mass of C2H6O2, let's first find how many moles of ethylene glycol we have. Okay, so bago natin makuha yung molar mass, kailangan muna natin hanapin yung molar concentration of C2H6O2. Okay, in order for us to get that, we will have to use the equation LTF is equals to KFM. Okay, remember this. So, since ang hinahanap natin is M, let's rearrange this equation to M is equals to delta TF divided by KF. And we know that delta TF is equals to the negative T solution minus T pure solvent. Negative T solution minus T pure solvent divided by KF. Okay, so M is equals to the new temperature of the solution is negative 1.31 degrees Celsius minus 0.00 degrees Celsius divided by, so yung KF, since KF is water, nasabi ko kanina hindi naman nagbabago yung KF ng H2O, so this is still 1.86 degrees Celsius per M. Okay, So M is equals to, saan natin ito nakuha? It's from the previous problem. And it's common knowledge na I want you guys to remember is the Kf of H2O, hindi ito nagbabago, is always equals to 1.86 degrees Celsius per molal. Okay, using the calculator, you would get that the molal concentration of ethylene glycol is 0.7043 molal. Or yung molal is equal siya, let's just change it to moles per kilogram. Okay, so remember, moles is equals to the moles of solute divided by the kilogram of solvent. So we can use this as its what we call units then. Okay, so after getting the molal of C2H6O2, let's erase this. After getting that, we can now find the moles of the solute. Okay, so how do we find the moles? Here we find the molal. Okay, malito dito, molal. Dito ngayon ang hinahanap natin is yung moles ng solute, which is C6H6O2. To get the moles of solute, what we can do is to multiply the mass of the solute or solvent to the molar concentration. Okay, so yung molar concentration natin is 0.7043 moles per kilogram. And yung mass ng solvent natin is 100 grams, which is equals to 0. kilograms. Okay, so by multiplying these two, we can get the moles of our solute. So the moles of our solute is equals to 0.7043 moles per kilogram multiplied by 0.1 kg. Okay, so canceling that, we'll get that the moles of solute would be equals to 0.07043 moles. Okay, so that is the moles of C2H6O2. So now we have the moles, and we just need the mass of our solute to find the molar mass. So to find the molar mass, we just need C2H6O2. Okay, so the molar mass is equals to the mass divided by the moles. And the mass given by the problem is 4.35 grams. And yung moles, yung nakuha natin kanina, is 0.0743 moles. And then yung molar mass natin is equals to 61.76 grams per moles. Okay, so the molar mass of C2H6O2 is 61.76 grams per mole. So that's how you get the molecular mass of your solute. Again, what you need to do is first, since in order for you to get the molecular mass, you need to get the mass and the moles of your solute. So in this case, ibinigay naman yung mass ng solute. Ang hindi binigay is yung moles ng solute. You can get the moles of solute using the molality. So you have to get the molality muna ng solute ninyo or ng solution ninyo. And using that molality, you can get however or how kung ilang moles meron ka ng solute. Okay? And after doing that, you can get the molecular mass by dividing the mass of your solute to the moles of solute na nahanap mo. Okay, so I know this can get confusing, but try the same problem on your own, guys. If you guys meron kayong question, just try and message me. I'll help the best way I can. Okay, so that's how we can determine the molecular mass of solute using the information we have from the colligative properties ng solution. Okay, so lastly, pag-usapan natin is yung electrolyte and non-electrolyte. As we've discussed, yung colligative properties, nakadepende lang siya dun sa number of solute na present dun sa solution. So meaning, yung colligative properties, it doesn't care kung ano yung nature ng solute ninyo. Ang gusto lang niya malaman is gaano karami yung solute ninyo. So, meron two types of solutes na pwedeng ma-dissolve din sa solution. One is an electrolyte solute and the other is non-electrolyte solute. Electrolyte particles or electrolyte solute or solutes that are electrolytes in the solution ionizes in the solution while non-electrolytes do not ionize. Meaning, yung solute ng non-electrolyte remains the same structure after it dissolves in the solution. Ang mangyayari sa electrolytes, meron tayong dalawang klase ng electrolytes, strong electrolyte and weak electrolytes. Under strong electrolytes, we have ionic compounds, strong acids, and strong bases. Under weak electrolytes, we have weak acids and weak bases. What do we mean is if we have ionic compounds, strong acids, strong bases, weak acids, and weak bases as solutes, ang mangyayari dun sa solution nyo, magiging siyang electrolyte solution because these are electrolytes. Pero if you have a polar covalent compound, example sugar, if you dissolve the sugar in your solvent, let's say example water, hindi mag-ionize yung solution ninyo. Yung sugar, it remains the same structure after it dissolves in the solvent. Unlike sa mga electrolytes. Kasi nangyayari, ang electrolytic solution have greater effect on colligative property because the atoms ionize and or dissociate in the solution. What that means is, for example, you have a solid NaCl. So, meron kang solid na asin, di ba? And kapag dinisolve mo siya sa water, ang mangyayari is actually magdi-dissociate yung dalawa. Magkakaroon ka ng sodium cation sa aqueous solution kasi nilagay natin siya sa tubig. And then sa same solution mo, sa aqueous solution mo, meron kang chlorine and ion. Ito yung tinatawag natin dissociation. Maghihiwalay yung dalawa. And this is true for all electrolyte solution. Similarly, magkakaroon ka rin ng another way is ionization. Halimbawa, you have HCl, which is a strong acid, aqueous solution, and you dissolve it into water. Ang mangyayari, mag-ionize yung water, you would get a positive hydronium. And hydronium is basically a H cation or H+. And this H+ is sticks to the H2O. That's why we can write hydronium or H+ as H3O+, kasi meron kang extra H. And also, this should be negative, not 1. Yung Cl magdi-dissociate siya, you would have negative or chlorine cation. So, ito yung nasa loob ng solution mo. Unlike sa non-electrolyte, kapag dinisolve mo yung sugar, sugar pa rin siya. So, yung C6, H12O6 mo na sugar, sa loob ng, halimbawa sa water, sa loob niya is C6H12O6 pa rin siya, yung sugar. Hindi siya magbabago. Unlike sa mga electrolyte solution, magbabago yung, so this is H2O plus sugar. Again, yung sugar na solute mo, hindi siya magbabago. Unlike dito, magbabago yung number of solute mo sa number of moles ng solute mo kasi magdi-dissociate siya and mag-ionize siya. Kaya nangyayari yung mga electrolyte solution actually has greater effect. Assuming na complete dissociation, yung 1 molar of aqueous solution of NaCl actually contains not 1 moles but 2 moles of ions. 1 mole for Na cation and 1 mole for your chlorine anion. Unlike sa sugar mo, kung may 1 mole of sugar ka, 1 mole pa din yung nasa loob ng solution mo. Pero sa NaCl and sa weak acids, strong acids, sa mga electrolytes mo, mag-iiba yung number ng moles mo. Mas madami sila kasi nagdi-dissociate sila. So you have 2 moles of ions per each kilogram of water. Hence, its freezing point depression is expected to be just kfm. So yung kf ng water is 1.86 degrees Celsius per molar. So ang molar is equals to kilogram per mole. I just changed it to kilogram per mole. And 2 moles of ions per kilogram of water. And yung delta TF mo is equals to 3.7 degrees Celsius. So meaning, yung freezing point nung solution is negative 3.7 degree Celsius. Pero in the real laboratory setting, yung actually kapag ginawa mo siya sa real lab setting, this is theoretical, okay? Ito lang yung theory. Pero kapag ginawa mo siya sa lab setting, ang makukuha mo is actually 3.4, which means some of the NaCl actually did not associate. So medyo mas complicated kung electrolyte solution yung sinosolve mo for delta dun sa freezing point depression and boiling point elevation. So ang gagawin natin ngayon, since for all the intents and purposes of this course, we're gonna focus more on non-electrolyte solution. So for the duration of our course, we'll only be using non-electrolyte solutions. So yung mga napag-aralan natin kanina, yun yung mostly gagamitin natin. Kasi kapag electrolyte solution ang gagawin natin, medyo ibang equation na ang gagamitin natin. Actually, you would have another constant. And we're not gonna study this for now. Maybe when you go sa college, you can study this. But for the intents and purposes ng course natin, we're gonna stick with the non-electrolyte. But I hope you guys understand bakit mag-iiba kapag electrolyte solution. Dahil simply because magdi-dissociate siya. So kapag nag-dissociate siya, imbes na isa lang yung solute mo, nagiging dalawa siya. So halimbawa sa NaCl, imbes na isang molecule lang ng NaCl, magkakaroon ka ng dalawang solute, isang Na, isang Cl. So iba yung pagsulat natin sa mga electrolyte solution. Okay, again, so focus lang tayo sa non-electrolyte solution, which is yung ginawa natin kanina. So kung meron kayong question about sa colligative properties ng solutions, just message me, okay, Maya, and I hope you guys have a great day, and thank you.